Hi, my name is Haley, and in this lesson I'm going to talk about block ciphers. First, we need to find out what a block cipher is. Block ciphers are not algorithms that actually encrypt text. Block ciphers are simply a method to use an existing cryptographic algorithm to encrypt plain text. Block ciphers only work with symmetric algorithms. Symmetric algorithms have a single shared secret key. Now that we know what block ciphers are, let's discuss how block ciphers work. Block ciphers split up the plain text into groups of letters called blocks. Usually the blocks would be around 64 bits, but the blocks can be larger. For example, 8 bits is equal to 1 character. Each block of characters get encrypted by the same key and the same encryption algorithm. The resulting ciphertext is the same as it would be if the letters were encrypted in sequential order. Here is an example. Suppose we want to encrypt the text on a dark and stormy night. With a symmetric algorithm, I've chosen the block size in the example to be 32 bits, which is 4 letters. So the first thing that would happen is the text would be split up into 4 character blocks. Then each block would be encrypted by some symmetric algorithm using the same secret key. Finally, the ciphertext blocks would be joined back together to create the final encrypted message. To decrypt the message, we would simply reverse the process using the same block size of 4 characters and the same secret key. The last piece of the block cipher puzzle is the modes. A mode of operation describes how to repeatedly apply a cipher's single block operation to securely transform amounts of data larger than a block. Some of these modes are more secure than others. The possible modes for block ciphers are electronic code book, cipher block chaining, cipher feedback, output feedback, counter, and counter with CBC MAC. On this slide, I'll demonstrate how the electronic code book mode works. First, we demonstrate the block size and a secret key. First, we determine the block size and secret key. Second, we split the text into blocks. Third, we encrypt each block using the designated key. Finally, we join the encrypted blocks back together to form the final ciphertext. The decryption process is identical. You would just have to use the same secret key. Block ciphers have many uses. On this slide, I've listed 2 possible applications. Block ciphers that utilize the Advanced Encryption Standard algorithm, also known as AES, is used in counter mode for protecting data at rest on storage systems. This system is very secure. Block ciphers can also be used for data transportations. All modern web browsers come with transport layer security. This protocol provides AES encryption to encrypt communication between endpoints. Now we will talk about the strengths and weaknesses of block ciphers. Some strengths are that this can be very fast for encrypting large amounts of data if the block mode supports parallel processing. Also, if an error occurs, it will only affect the current block and not the entire message. Some weaknesses are the ECB mode only suitable for short messages. The ECB mode must have a full-size block, and non-ECB modes cannot use parallel processing, making them much slower. The cryptanalysis should hope that the message is not encrypted using the ECB mode and the message is short. The reason that this is important is that identical plain text blocks will always result in the same ciphertext blocks. When encrypted using the same key, the cryptanalysis can use a frequency analysis to attack the message. If the message was encrypted using the Advanced Encryption Standard algorithm with a strong mode, then the ciphertext would be considered unbreakable using current computers. Here are the references for the articles that I use in this lesson. If you have questions, please don't hesitate to ask them in Canvas. Thank you.